Okay. Okay. So given a function, here's a picture. Okay. And this is a two lines, coordinate lines, and this is a and here some we have so-called domain. Usually it's interval here, and this is a range. Okay, given point value of x, given a value x, then you assign another value, and this assignment we call the f. Okay. Okay. So that's called the definition. Okay, of the function. Okay. Now. How to, there's many ways to describe a function. Okay, this is called the, the two coordinate line. If I put the two coordinate line perpendicular to each other, then you have x here, right? So suppose x here, then the corresponding y is here, right? So those two numbers gives you a point in the xy plane, and then. And this is much better to describe the function, right? Then when x changes, you get a bunch of points. So you get so-called graph, okay? So this is this will be called as a graph of the function f, okay? And sometimes you're not given the graph of the function. Okay, you are given a formula. You can define the formula. Function f can be defined, can be described by a formula. Okay, so the formula is y equals f of x. Okay, so you have to give me a formula. Otherwise, how do you assign a value to any given value of x, right? How do you assign a y value to a given value of x? And usually you are given a formula, okay? Given the formula f of x. So then you can set up this correspondence, okay? Build up this correspondence. And for example, okay, fx is going to be x squared, okay? For example, fx squared. Then it's clear that anytime you give me the value of x, I get another value. Okay, this is called the y value, right? So y equals x squared. Okay, just squared. Okay. Well, right? If 2, then 2 become 2 squared. So that's a so-called function. Okay, a function usually is denoted by f because that's the initial of the word function. Okay, but if you have more than one function there, you can use different letters such like a G or H. Okay, if you have more than 26 functions here, then you can label them like a F1, F2, F3, F4. Okay, or you can use a name to name a function, any kind of name, John Smith, of X, right? So this is a kind of doesn't matter if you write the programs, you know how to write the program, you can use many letters to describe and give a name of the function. Okay. So this is about function, but you will see that sometimes not all the x will be given values, and so there's a restriction x, and this will be called as a domain of f. Okay, and then you probably will not get all the values of y. Okay, maybe y can be only positive or can be negative, right? And those they occupy some they occupy an interval, and that is called the range of f. Okay, so ranges of f is kind of image of the domain and the function f. Okay, so look at this example. If I do not put any restriction on x, then clearly the domain of this function is going to be the whole line. Any x can be, right? That if there's no restriction, then that will be the domain of the function. Okay, but the range of the function is not the whole line, you know, because you square it. Okay, if you square it, then if you square it, then you always get non-negative number. So the range of this function is from 0 to infinity. Okay, so that is the domain and the range. Okay, so let's look at another example. For example, the formula for the function is going to be x minus 1 or x plus 1. I would, if I do not specifically mention the domain of f, so what is the domain of this f, right? Implicitly, it's given by the formula, okay? So by definition, the domain of the f is going to be the set of x for which the function is defined, okay? So the domain of f is going to be those x. I put the condition there. So that f of x is defined. When f of x is defined, when x plus 1 is not going to be 0. Okay? So x cannot be negative 1. In other words, right? X cannot be negative 1. So therefore, if you want to express use it as an interval, then you just the whole line delete the number negative 1. So it's from negative 1, from negative infinity to negative 1, uni from negative 1 to 1. So it consists of two separate intervals. Okay. Now, how about the range? Well, it's a little difficult to find out the range, right? Yeah, it's not easy to find the range here. Okay. Yeah. So let's try and do our best to find the range. Okay, I have to rewrite this function. X minus 1 becomes x plus 1, right? Then minus 2. How about this? So I get 1, right? Because x plus 1 over x and minus 2 over x plus 1. Okay, then it's easy to understand this. This is a number, okay? This number never be 0, but it can be any number which is not going to be 0. Okay, this 2 of x plus 1 can be any number between any number except for 0, right? This never be 0, right? But it can be any number. 2 plus x plus 1 can be any number. Let's say any real number. Why? For any real number, I can solve for that. X plus 1 equals 2 over r. X equals, as long as I choose x to be 2 over r minus 1, then 2 over x plus 1 is going to be r. So any r not going to, any if r is not going to, for any non-zero r, I can always find x. Such that 2 over x plus 1 equals r, okay? Right, so that means this can be any. Then 1 minus non-zero number, right? So clearly fx cannot be 1, right? Otherwise 2 over x plus 1 is 0. And then f of x can be any, attains any values which is not equal to 1. Okay, so then it's clear that the range of f is going to be any y is not equal to 1, okay? Right, so that's it. I use a y not as x. It's okay, just a variable, right? Okay. So that is a domain, okay? And that's a range and domain, okay? So the range is domain. This is cannot be negative, right? So this is right here is x, and here cannot be positive 1, okay? This is any y, right? So it's going to be like that. This is and given by y equals x minus 1 x plus 1. That's the relation, right? That's the whole picture for the function. Okay. For any x not equal to negative 1, you can assign the value y, okay, by this formula, x minus 1 over x plus 1. And you see that when x is equal to negative 1, I cannot use this formula to assign the value. And also that gives you the domain, right? Then you also see that the image of x and the f never be equal to 1. Okay, so this is a domain. I simply write df, this range. Okay. Now, can I reverse this procedure? Can I reverse this procedure? Sometimes, yes. Okay. Can I reverse this procedure? And if I can do that, then this inverse procedure, okay, gives a new function. That new function I'm going to denote by f negative f to negative 1. Okay. So all I have to do is just find the, just reverse the procedure. A given value of y, which is not going to be 1, can I get x such that its image is y, right? Basically, this is called inverse. All we have to do is just solve it, right? Given y not equal to 1, okay, we try to solve this this equation for x. Okay, that's easy, right? As long as you understand the concept, that'll be easy, right? Then you find the inverse, right? Okay, so how can I do that? X plus 1, y, x minus 1, okay? Then I'm looking for x, so okay, then I needed to move this to there and this to the other side. So I get x, y minus x, negative 1 minus 1, okay? Yeah, then I have to factor x out. Okay, then you divide both sides by. All right, now you can multiply the numerator and denominator by negative. So you can write it like this, 1 minus 1, okay? That looks better, okay? All right, so that means you, that means a given value which is not equal to 1, you can find a unique value of x so that its image is going to be y, right? So you solve this, so actually, so this is going to be denoted by f inverse. Okay, we read it, f inverse, the inverse of f of y. Okay, so we define, we find a new function. Okay, we find a new function, and this is called the inverse of function. And this relationship, it defines the inverse. Okay. All right, so we get an inverse function. Now in general, okay, this is very, let me repeat the picture here. This is x, that's f and y. If you reverse the procedure, okay, then you get the inverse, okay? So y is going to be equal to f of x will be equal to the inverse of y, okay? Right? Okay, but not always we can do that. Sometimes we are not able to find the reverse procedure, okay? This can be done only when f is a so-called one-to-one function. That means it sends 2 different points to 2 different points. If you send 2 different points to 1 point, then you cannot reverse the procedure to get a new function. Okay. Right. So this is the inverse, and then look at this. Right. So the domain of f becomes the range of the inverse function, right? Yeah, because it's coming back from it, right? And the range of the function becomes the domain of the inverse. Okay. Right? Right. Another important property is since y equals f of x, right? But f of x is going to be, x is going to be the inverse of y, right? Then if we look at here, x equals f inverse y, and the y is from the f, right? Y is going to equal to f of x. So you have 2 important identity. Okay, you can verify this using the examples, but this is a, yeah, this is what we get here. And then let's take a look at the example, another example. It's my favorite example. So f of x equals x. Now, there is no restriction x, so let's find out what is the domain. Okay, we know that if I draw the picture, the original picture, x, yes, this is 0. So here's the point, this is 0. X becomes x squared, right? But negative x also send it to the same point. It's going to be negative x squared, so it's the same value. So this map sends two different values of the opposite sign to the same number, okay? So clearly the inverse doesn't exist because there's no unique choice here to reverse the procedure. Now how can you define the inverse, right? So I think from this picture, the inverse doesn't exist because you must assign one value for any x to any given y value. But when you reverse this procedure, then so oops, which way I can go? There's two ways. You come right. Y comes from two different x. You have to make a choice unless you design. Okay, define some way to make an automatic choice of the x value. Otherwise, you cannot reverse this procedure here. Okay, so in this case, the inverse does not exist. Okay, we said it in mathematics. However, still the same formula, but I put a restriction on that. Okay, so now the formula the expression for the formula is similar, exact same. However, there's a restriction here. Okay, then you actually get a new function. This new function, the domain of this new function is from 0 to infinity. And the range of this function is also from 0 to infinity, right? Right? But in this case, we can reverse the procedure because this is from 0 to 1, right? Okay, the domain is going to be this part. Okay. The range is also from 0 to infinity. So that is a range. So there is a corresponding, one-to-one corresponding. So if any x, you get the y value, right? Y is going to be x squared. And then you can reverse that. There's a unique way to go. Okay? So you get x, right? How can I get it? X is going to square y. See? Yeah. And it's because we already assume that x is positive, right? So x is positive. So this is you just solve for x in terms of y, and we know x is positive, so there's a unique solution for x. Okay. So f of x is going to be x squared greater than 0, and the inverse is going to be square y, and the y is going to be greater than 0. Okay. All right. Now we want to find the derivative of the inverse function. Okay. How to do that? Okay. How to find the derivative of this function? Okay. Well, let's try, okay? Sometimes you're not able to express the inverse function by elementary, by elementary function. So you're not able to differentiate. But like the one above, right? We can do that. F of x equals x squared greater than 0, right? And then you have this, right? Okay, so therefore you can find the derivative of y, right? It's just the root of square root of 5, right? So, and the y cannot be negative. Okay, when y is 0, you don't have derivative. Okay, so you find this, no problem. So as long as you're given the formula, okay, using elementary functions, such like a square y and sine y, cosine y, then you can find the derivative. All right, now let's take a look at the next problem. Given 2x minus 8x, x is greater than or equal to, right? Find the inverse, if it exists, and the derivative of the inverse at 0. Okay. All right, so let's understand this function. It's 2, take 2 out, right? X squared minus 4x. It also can be written as 2x x minus 4. Right. Okay, let's draw the graph. Okay, this is a parabola, opens upward, right? And here's 0, here's a 4. And this will be 2. Okay. When x is greater than 2, I'm talking about this piece of graph. Okay. So this is a graph of the function y equals f of x, right? It's increasing. So what is the domain of this function? Because x, you're assuming x greater than or equal to. The domain of this function is from 2 to infinity. And I think it's clear the range of the function. So what is the vertex point? When x equals 2, what is y value? When x equals 2, I'm going to do the calculation. 2 times 2 minus 4. So it's going to be negative 8. Okay, so this is the lowest point on the graph. Okay, negative 8. Yeah, we have a 2. Yeah, let me mark it the domain. Domain is this part. Okay, and the image is this part. Okay, so it's going to be from negative 8 to positive infinity. Okay. Now, the inverse exists. Okay, the inverse exists. How do you do that? Well, here's x, right? And you go up and draw this one. This is a y. Okay. All right, so this is why, and I'm going to find the formula how to reverse the procedure, right? I know this y is going to be 2x squared minus 4x, right? How can I get x expressed in terms of y? And I reverse the procedure, right? All right, so what I'm going to do is just set y to be 2x squared minus 4x. Okay, I'm trying to solve it. It's a quadratic equation, right? So I get 2x squared, I still use 8x minus y equals 0. And I solve for x. Okay. I'm solving x, okay? All right, so use a formula, quadratic formula. It's 2 times 2 here, right? Negative b, right? Plus minus b squared minus 4ac. Right. So that's from the quadratic formula. So I get 4 here, 8 plus minus 8 squared plus 8y. Right. Okay. I can, I don't need to, I probably take a 4, yeah, take some number out, right? I take a 4 out. Okay. If I take a 4, you can simplify it, right? If you don't want to do that, it's just 2 plus minus a quarter, and you can take 8 out, the 8 plus 1. Okay. Okay. So since y is, yeah, this is x, right? Okay. Now, what is the inverse part? The formula for the inverse function. Okay, the formula for the inverse function, because our x is greater than or equal to, right? Our x is greater than or equal to. So the inverse part, yeah, it's going to be plus. Okay, then you can always say that's greater than 2, right? Okay, that's the x. And the domain is y is greater than, y is greater than equal to negative 8. So this is a formula for the inverse function. Okay. So the range of f, the inverse, is going to be domain of f. It's going to be from 2 to infinity. And the domain of f, this is just range of f. It's from negative 8 to positive infinity. Okay. So how do we find the derivative? Well, you can use the formula, right? You can use the formula, this formula, because you find it. Sometimes you cannot find it, okay? So use a formula, then I have to differentiate, right? So this, how do I differentiate? This is going to be a quarter, right? This is a quarter, 8 plus y to the 1/2. So it's 1/2, right? And 8 plus y to the negative 1/2. Then I differentiate inside is going to be 8, actually, right? Okay, after you simplify it, you get something like that. Okay. So when y equals 0, it's going to be square root of, right, 8, right? 8 times 8, 8 squared, so it's 1 over 8. Okay. You can find the derivative, no problem, right? If we're able to find the inverse, okay, function. Now, is there any better way to solve this? Well, we have to develop a formula, okay? Y equals F inverse Y. This is identity, right? So use a chain rule. You can find the derivative. It's the implicit differentiation, right? Okay. The left-hand side is 1. The right-hand side is the derivative of F. Okay, then the derivative of the inside function. So that is a formula. Okay, so we have okay, so this will be the formula. Okay. To use this formula will be much easier to solve the problem. You don't need to express the formula for the inverse function. Okay. Okay, so this will be F prime. Okay. Now the only problem is how do you find this? Well, this is easy to get. Okay. The reason is, okay, the reason is F. The reason is you have Y, right? What's the relationship? Y equals 2x squared minus 8x, right? So when you get here, when the that's right, trying to get x, right? So this y equals f of x, and the inverse of y, right, is going to be x. So when y is 0, what is x value, in other words, right? Okay, so 0 equals 2 times x minus 4, right? So clearly x either be 0 or x equals 4. Well, our x should be positive, and that's our definition for the function, right? Yeah, let's go back to here. Our x somewhere should be here, right? Yeah, our x is greater than or equal to 0. We already said that at the very beginning. So clearly x equals 4. So that means 4. Okay. So if you plug into the formula, you can apply equals 4, right? Then it's easy to differentiate the function, original function. Okay, so original function f(x) equals 2x squared minus 8x, f prime x equals 4x minus 8. Okay, so that's why it equals 4 times 4 minus 8, 1 over 8. You see, you get the same answer. Okay, you get the same answer. All right. Now, this time we're still lucky. We can find the elemental formula for the inverse function. Okay, there are some problems we are not able to express the inverse function using elementary formula. Okay, it's difficult at least. So, for example, let me give an example. Yeah, I have an example here. X cubed plus 3 sine x plus 2 cosine x. Okay. I'm not asking you to find the formula for the inverse function, but I want you to find out the derivative of the inverse function at the 2. Okay. How do you do that, right? If you're not able to find the formula, you're not able to do it. Right. Well, we do have the formula, right? So if step 1 is we have to write down this first. Okay. So this is our formula. If the inverse exists. Right. So if f prime exists, otherwise you cannot find the inverse. Sometimes derivative inverse, right? Yeah. So let's take a look at this Okay, so here's a function, right? You're given a very complicated function. X cubed plus 3 sine x plus 2 plus cosine 2x. Okay. And we want to find the we do not, okay. We are not asked to find the inverse formula for the inverse, but we want to find out the derivative of the function. Okay. At 2. How do you solve this problem? Okay. Well, we use a we use a formula. Okay, we just got it, right? Yeah, let's go back to the formula. This is how do we get the formula, right? We use the identity for the inverse, the relationship between inverse and the origin function. We differentiate both sides with a chain rule, and we get 2 parts here, and then this is a derivative of the inverse function, and then you solve for that by dividing f prime on both sides, so you get this. So this is the formula. Okay, this formula we can use to find the derivatives. All right, so now we are given we are given a function type. If the inverse doesn't exist, then you don't need it to find the derivative, right? So first thing we have to do is ask yourself, does the function have the inverse? Yeah, question 1. Does f have the inverse? Okay, although you're not asked to prove this claim. Okay. Okay. Second, what is this, right? Okay. After you solve after answer these 2 questions, then you are able to find the derivative of the inverse. Okay. Anyone have ideas how to prove this has an inverse? Okay. But in order to make sure the function has an inverse, the function must be an increasing function or decreasing function. If it's going up or down, like the parabola, then this function doesn't have inverse because you cannot reverse the procedure. Okay. Okay. On the graph, it's easy to see that. So to prove this one has an inverse, all I needed to do is it's an increasing function or decreasing function, but we can differentiate. Okay, find the derivative. Okay, find the derivative. I get 3x squared plus 3 cosine x minus 2 sine x. Okay, that's a derivative. Okay. Well, you still cannot tell this one is always positive or negative, but for larger x, this can be positive. It's not easy to prove this, but it has the inverse. Okay. Okay. We assume it has the inverse. What is the possible value for the inverse of that? Inverse function evaluate 2. Okay. I note that when x equals 0, I get 0 cubed plus 3 sine 0 plus 2 cosine 0, which is going to be 2. So And for x close to 0, okay, this is almost 0, this is almost 0, only this one is close to 3. So we know that f prime x is going to be positive for x close to 0. Okay, so that's why I don't need to know the whole graph, at least nearby 0, right? This is a 2 here, the value is 2. So the function is the increasing function because the derivative is positive. So then the inverse exists, okay? The inverse exists for that piece, okay? So here's the x, then you get the y because it's the increasing function. So you can go back to get x, okay? So now you can use a formula, okay? You can use a formula, okay? Okay, so that is going to be 0, right? Okay. Because the inverse exists. So so now you have to find the derivative, right? Of the function. You already find the derivative. The derivative here is 3x squared plus 3 cosine 0 minus 2 sine 0. Okay, so the answer is 1/3. Okay, so we find the derivative. Yeah, most of the time you don't need to check to verify this function has a inverse or not. Okay, you just assume it has inverse. Okay. And let's try another one. Let's go here. All right, so take a look at this function. I want to find out the derivative of the inverse is 0. Right? Clearly, this one has a derivative has an inverse because the derivative of this function is going to 5x to the fourth power and 9x squared and plus 1. This is always positive, right? Always positive because every term is positive. Okay, so f, it's the increasing function, so that implies the inverse exists. But can you find it? No, you are not able to find it. So how do you find the inverse, right? So what you do is, trying to, in order to find it, in order to find the this, one has to solve this equation. for x, right? So this is the f of x, right? When you solve for x, you will get something like that, right? Right? Just move f to the right, left-hand side. But are you able to solve it? Now, this is a polynomial degree 5. I don't have any formula I can use to solve for x. So it's impossible. But I know the inverse exists. Not only that, I can see, I also can see that, you see that, you note, right? F0 is going to be 0 to the fifth plus 3, 0 cubed plus 0, right? It's a 0. Right? So zeros should be equal to the inverse value of the function. The value of the inverse function at 0 is going to be 0 also. Okay. But I still cannot find the formula for the inverse function. Nevertheless, we can find the derivative of this unknown function, okay, using the formula. By the formula, okay, I'm able to find the value of the derivative at 0, okay? Okay. Okay, so this is the formula, right? So I already know this value is going to be 1. That is going to be 0. So it's increased by 0. Next step is just find the derivative and evaluate. And we already know the derivative, right? We did that at the very beginning to prove that the function is increasing. And the derivative, yeah, it's 5x to the fourth, right? 5x to the fourth power, 9, 0 squared, and plus 1, so which is 1. That, so this example tells you that in some cases you are not able to find the inverse formula for the inverse function, but you're still able to find the derivative of the inverse function at some given point. Now, okay, let's take a look at the next problem. F of x is going to be 1 minus square x, 1 plus square x. Okay, find the inverse. Okay. How do you do that? Well, all you have to do is just set y to be f of x. Okay, then you try to solve for x, right? Okay, then you solve for x. Solve it for x. Okay. Yeah, remember y equals f of x. When you solve for x, you get the inverse formula, right? The formula for the inverse function. Okay, let's solve it. How do you solve it, right? You multiply both sides by 1 plus square x. So we get y plus square xy equals this. Right. So this one contains x, this one contains x. They should put together. And the other one is 1 minus 1, right? We want to move to this side, this to the left hand side. Okay, so now you fact square out x out, right? And try to solve for x, but you solve for square x first. Solve for square x first. Right, so square x equals 1 minus y, 1 plus y, right? Yeah, then you square it. X is going to be, okay, so you get the formula, okay, it shows how does x depend on the y variable. So this is our inverse, the formula for the inverse function. Okay, then you can find the derivative. Once you have a formula, you can find the derivative, right? I haven't mentioned the domain and range here. Yeah, it's a little bit complicated for the domain and range. Right. I can, yeah, we can go back to look at the function, right? What is the domain of the range? Okay, so f of x equals 1 minus square x, 1 plus square x, right? The inverse is this, we already find out. Okay, what is the domain of f? Right. You look at this expression. Square x cannot be equal to 1, right? 1 plus square x cannot be equal to 1. That cannot equal 0. So that's clear. And then this should be defined, right? So that means x cannot be negative. But once you can compute the square root x, and then 1 plus square x will never be 0. So it's this satisfying automatically. This one you have to say x cannot be 0. Okay. So that is a domain of the function. But the range of the function would be a little bit difficult to figure out. But from the inverse function, you can see that x cannot be, y cannot be negative 1, right? Yeah, to find the range, it's not easy. Yeah, the way I try to get it is using this identity. I put a negative 1 here, square x, and then I add a 2 here, right? So you separate them, it's going to be negative 1 plus 2 over 1 plus square x. So what kind of value you can get here? So 2 over 1 plus square x, clearly this is always positive, right? Right? but this is always less than or equal to. The reason is 1 plus square of x is greater than or equal to what? So now it's clear, right? This number, the second part, the number is between 0 and 2. So the range of f, when this one is getting close to 0, it's going to be -1. I think this is a yeah, it's positive. Yeah, this can be when x equals 0. You get that -1 plus 2 is 1. Right, so this is the range of the function. Right, it's not easy to find out, okay, the range. But it's easy to find the domain. Right? But my next problem I want to discuss is about the sine function. Okay, so y equals yeah, just take a look at sine x. This function, if without a no restriction, it does not have an inverse, okay? Because it's not like a one-to-one function. So what I'm going to do is I'm going to put the x to be -2, put a restriction on x. Okay. Then this function, the domain is from -2 to +2. So it is a increasing function. Okay. Right. This is a picture. So from here, it's easy to see why the inverse exists, because given a value of x, you can go up to the graph and then go to left, you get a y value, right? Y equals sine x. I can reverse this procedure. Right? Going back down here, right? So x is going to be the inverse. So we denote, you see, we have 3 letters for this function, sin. So it's not necessary to use one letter s to denote sine x, right? Otherwise, we'll be confused. Okay. Can we use the 3 letters here this time for the function called so-called sine x? All right. Am I able to find the inverse function? Possible. Or maybe not, right? Okay. But I want to find the derivative. I want to find the derivative. I'm maybe not able to find another express formula for the inverse function. Okay, how do I find the inverse with the derivative of the inverse function? By definition, this is going to be sine, right? The sine becomes cosine, right? The derivative is going to be 1 over cosine. So now that's a formula, okay? But I'm not satisfying this. Are we able to change it? Okay. Right? Can we express this denominator without using the inverse function? Yeah, think about this, okay? Okay, how do you solve this problem? This is a trigonometric problem, right? So how can I express this without using sine cosine? I can do that, okay? So I let theta to be sine y. This is the angle, right? Now what you can get from here? Well, you can get two things. Sine theta is going to be y. Also, I know that theta is between negative pi over 2 and the positive pi over 2, right? Okay, what do we want to find out? We want to find out cosine theta, okay? Well, if you know sine theta, you can get cosine theta, right? Why? Because cosine square theta plus sine square theta equals 1. Okay, sine theta is a y, so cosine square theta plus y square equals 1. Okay, then cosine square theta equals 1 minus y squared. Then you have to solve for cosine theta. And it's plus minus. But you already know the theta is between negative pi over 2 and positive pi over 2. So cosine theta is going to be positive. So you only take this. Okay. There's no negative sign. All right, so we find the cosine theta. So that gives me the derivative. It's going to be this. This looks much better. Very interesting. I'm not able to express the inverse function of sine using the well-known elementary functions like sine cosines. So we have to introduce a new. We have to view it as a brand new function. Keep the notation sine negative 1. Okay, I cannot rewrite. But when I differentiate this function, I find out the derivative, okay, as a function can be expressed using much more elementary function like a square root. Okay, that's interesting, right? So that is a derivative. So you can integrate right? You can integrate, and the left-hand side will be okay. So the inverse function, and I have to specify the value, right? When this is going to be 0 to 0, so 0 and the y, I'm going to change the parameter here, t and t. Okay, so I cannot express the inverse function directly using element function, but I can express as integral of some elementary function. That is what, right? So this is the inverse formula, inverse function. Right. Similarly, we can do for the exponential function. Okay. But anyway, this is the inverse function now. This is formula. Okay. So when you differentiate, you get 1 over square root 1 minus y squared. Okay. So this is a nice identity. Okay, you can you can find the derivative of the inverse function cosine x and so on. All right, last few minutes, I'm going to talk about the relationship between the inverse and the inverse function. Okay, so traditionally, right? Yeah, don't be confused. So this is y equals f of x, the graph. Okay, so given x, you get y values. Okay, so x equals f of x. X is the inverse of f of y, and the y equals f of x. Now, if we reverse this procedure, right? So given y, you can get x. so this relation, so x and y are related by the point on the graph. X and y are related by either of this equation. Okay, so this graph, this is a graph. This is a graph of the equation y equals f of x, or x equals the inverse of y. Then how about if I interchange the variable? So what is the graph of y equals the inverse? How it is related to this graph? Well, these two have the same graph, and these two equations just interchange to variables. Okay, so y equals f of x, and x equals the inverse function that gives us determine the same graph, right? Same graph. Okay. Now, but if we interchange the variable, okay, the graph of this function, this is y equals f of x. The graph of this new function, a new equation, okay, because you interchange it to variables. So there's a middle line here. Actually, you would get is it's a symmetric. Okay, it's a symmetry above this line. It goes like that. Okay, this is a y equals f. Okay, the reason is these two equations, you just interchange, it's a symmetric. With respect to the line y equals x. Okay. So that's all for today's class. I just want to tell you the relationship between the two graphs. If you change the variable, use x for the input variable for the inverse function, then the graph will be different. Okay, but they are both symmetrical with respect to the y equals x.